Last 2 minutes. Of course, I'm going to do something to it. It has 4 terms. It's in descending order. No greatest common factor. No negative leading coefficient. So then the first 2 terms have... Very good. What is left in parentheses? Good. So I need an x plus 1 coming out from the other 2. I write it before I look, like we did before. And now please tell me what it is. Very good. So then we have x plus 1 and x squared minus 4, which can be further factored. How? Good. Excellent. Degree? Good. Possible number of turns? Maximum possible number of turns. Doesn't have to turn at all. 2. Very good. Domain? Since it's degree 3 and the leading coefficient is positive, what is the end behavior? Excellent. Please let me know if this is not clear.
Is it always going to be negative?
It's like the linear function. Yep. Like the linear function with the positive slope.
So something I can just immediately write into the chart.
Yes, we had, yes, of course, we had that table that I created last time. Yes. Good. X-intercepts. How do I determine the x-intercepts? Very good. Awesome. So how many solutions will you give? Yes, because the degree is 3. Good. So please tell me what they are. If you set this equal to 0, that's why we factored it. Yes. Excellent. Multiplicity for each? Exactly. Multiplicity 1, multiplicity 1, multiplicity 1. So all of them will be what type of... yes. Sorry, negative 2, negative 1. I'll erase that. 0 and 2. Perfect. So let's find the y-intercept, please. Negative 4. The function cannot be symmetric, but I have to write that f of negative x does not equal f of x, and it does not equal negative f of x. Not symmetric. That's it. We're done. Let's graph it. As I said, please, 3 minutes. This is an important topic, but no one as important as others. So I don't want you to spend a tremendous amount of time on this, please. I start with what when I graph? I have to start with the points I have. I have to plot those. So negative 2, 0, negative 1, 0, 0, negative 4, 2, 0. So negative 2, 0 is this point, negative 1, 0 is this point. Oh, there, I forgot to write, they're all cross, not flat, just a regular cross to from one side to the other of the x-axis. Okay, so now let's do this together. Please pay attention for a second. The function is coming from negative infinity and crossing at negative 2, 0. Okay. Then it comes back to cross at negative 1, 0. Well, it has to have a turn. You cannot just jump. It's a continuous, smooth function. So it has to have a turn to come back and cross at negative 2, negative 1, 0. Now it has to cross the y-axis at this point. Well, there are several options. This option, or this option.
I mean, 2 turns, right?
So it cannot have more than 2, correct? But it can turn before crossing the y-axis. It can turn on the y-axis, or it can cross and then turn. That's my point. Is that clear what I'm saying?
Yeah.
Okay. So now these functions are continuous smooth functions. If I have to do this with my wrist to graph it, it cannot be true. It cannot be good. Okay. So if I do this, this is the natural way. This is very difficult. I have to twist my wrist. This may, but unlikely. So I think you chose the problem. I haven't looked at it yet. So I think that this is the situation. It will turn and cross again at 2, 0, going to infinity. If it's not, that's okay. We can adjust the graph. Because you're not supposed to know this in this class. We do this in calculus with no calculators, but not in this class. Yes?
So what if, like, I draw one graph and then he draws another graph? How do you determine?
You will look at the graphing calculator before you turn in your paper. This is what we're doing now because you have to determine the max. That's okay. That's okay. So we have to determine these. So you're going to, after you graph it, if you simply copy the graph from the graphing calculator, I can't give credit. So I have to see all the work. And then you will check. I will check with too, because we have to determine the max min. We can determine in this class. If you stay tonight, I'll show you how we determine the max min without a graphing calculator, but in my calculus class. Okay, so put in the
You go
function.
slow on this, but I literally forget how you do it every time. How do you get this pulled up on the? I know how to pull it up, but like you get all these other buttons by the time I can pull it up. And I get
But that's why I said that if you're falling behind or you need any help, always stop me.
I
Right?
am right now.
Okay, so you press on y equals. Y equals.
Okay, hold on. Oh, I'm messing up now. Okay, y equals.
Type in x cubed plus x squared. Tell me if you fall behind. Everyone.
I'm not type x cubed.
So you put x,
Arrow,
caret, and power 3. Let me know when we have the function in. Do we have the function in? We do? Yes? Now I want to adjust the viewing window. And actually, I don't really know. I have no idea. I'm assuming that this is tiny. I don't think it's going to spike too high. I think it's going to be tiny, but I don't know how low this one goes. But I know that this is -2 and 2, so I'm going to present from -4 to 4, and maybe from -10 to 5. Okay, ready? Although I do have a cheat sheet here that you don't probably. Okay, so let's go to the viewing window. I'm sorry? Oh, thank you. Sorry, my apologies. Okay, so I still had the -4 to 4, that's fine. And -2, of course, -2 for minimum is not going to be good enough. I'm going to choose -10 for now. And the maximum, I'm going to say 5 and see what happens. I can always go back and adjust anything I need. Okay, so it's pretty good. The graph shows perfectly. It's coming from -infinity, crossing at -2, having a tiny turn, tiny maximum, crossing it again at -1, 0, crossing as expected at 0, -4, coming to a minimum as expected because I felt that something wasn't wrong, right? Was wrong when I was trying to fit the graph through those points. So it has to be smooth, continuous, no effortless, I should say, okay? So crossing at -0, -4, coming to a minimum, going back to cross at 2, 0, going to infinity. So now we have to determine the max min. So I see the maximum is between -2 and -1. So we go to second and calc right here. This is calc, second and calc. And we want a maximum, which is 4. So between -2 and -1, press -2, enter, -1, enter. We have to give the boundaries, we say, to the calculator so the calculator knows where we are looking for a maximum. And then I don't want to guess, press enter,
I don't think so.
and it gives us the maximum. I think I pressed by mistake twice. Okay, so the maximum is at -1.54. -1.54, and the maximum is 0.88. Not a big maximum. And now I want to determine the minimum. And the minimum is between 0 and 2. So I go to second and calc. Minimum is 3. Let me know if you need help, anyone. Between 0, enter, 2, enter. I don't want to guess, just give me the minimum. So the minimum is at 0.87. And the minimum value is -6.06. So I put them in the table, -1.54, comma 0.88, and 0.87, comma -6.06. Any questions about this?
What did you do for
Say-
your
Say it again.
what did you do for your window again?
I used -4.4.
So I put -4 there.
Yes, -4.4 with a scale of 1.
And then 1.
Yes, and the minimum I chose -10 and the maximum 5. Yes, and this is just, yeah, let's see what happens. So it's coming from negative infinity, crossing at -2, 0, and crossing at -1, 0, crossing at 0, -4, coming to a minimum, and then crossing again at 2, 0. Is that clear?
Yep, that looks like that.
Great, excellent.
Thanks.
Thank you. What about the range of this function? Excellent, thank you very much. Great job. There is nothing else I can teach you about polynomial functions. This is it. As long as you fill up the table with the multiplicities, with the end behavior, with the degree, the maximum possible number of turns, and you come up with all the information in there, it should take you 3 minutes. I'm more than happy to do another problem if you'd like, or continue.
You can do another one.
Okay? Would you like to review all these examples first before we do another, so we can continue? Because I don't want to basically, I mean, I can do any problem, anytime. How do you feel about this? We need another example, please say so. Okay, very good. What degree? Odd degree. Excellent. This was odd degree. Very good. So let's choose an odd degree. From the factored ones, that requires a little bit less time. No, I want you to pick an odd degree. I want to make sure that we are on the same page with odd degrees. I see Marcus is already packed. You're not? Okay, good. I didn't want it to be packed yet. Can anyone choose an odd degree, please? Anyone? 58. Odd degree. Nope. 3 plus 2 plus 1 is 6. So 58 has degree 3 plus 2 plus 1. 57. 2 plus 3 plus 1 is 6. 66. 56. Okay, 56. 2 plus 2 is 4. It's not odd.
No,
63. 63. 2 plus 1 plus 1 is 4.
That was 5.
Which one?
It's 6.
2 plus 2. How much?
Plus 1.
Where is 1? You give a degree to -2?
No,
You
move
said
it
you
down.
have to add 1 and then the 2, there's a 1 exponent, right?
So x squared times x squared. We copy the base.
Never mind.
Good. So degree 3, 3, 1, 1. Here it is. 3, 1, 1. That's it. 64.
Thank you for picking.
Yep.
I don't.
Yes?
Never
You
mind.
just added those.
Yeah.
I'm lost.
You know how to multiply x squared by x cubed. You know that. I know for sure you do.
So if it's in the parentheses, don't hold the exponent outside of parentheses.
She just added them.
So, okay, so that's what I'm saying. So how do we multiply these two? We copy the base. What happens with the exponents?
6. Alright, fine.
Good. So that's what you do. So x squared plus 1 times x plus 1 squared. This is degree 2. This is degree 2. 2 plus 2 will be 4.
Alright.
Is that okay, everyone? Yes? Yes?
Yes.
Okay, perfect. So let's copy x plus 3, x plus 1 cubed, and x plus 4. So this is our function. Okay, so let's start with a degree. What is a degree? Yes, indeed. Degree 5. What is the maximum possible number of turns? Very good. It doesn't have to turn 4 times, but it cannot turn more than 4 times. Okay, what is the end behavior? Yes, negative infinity to positive infinity. Well done. Degree 5 behaves like the linear function with a positive slope. Excellent. X-intercepts, please. Anyone can give us the x-intercepts? How many? Yes. X equals, x equals, x equals. X equals. Excellent. Multiplicity. Excellent. Very good. Multiplicity. Very good. Clear? Okay, perfect. And -4, multiplicity 1. So this is a cross. This is a cross. But what does this represent? How will this one look like? Yes? Flat. But a flat cross. Very good. Awesome. So -4, 0, -3, 0, -1, 0, and also 0. Now it's finding the y-intercept is slightly more difficult. Tell me when you're ready for the y-intercept. And it's done. We can graph it. 0 plus 3. 0 plus 1. 1 times 3. 3. 0 plus 4. 3 times 4. Very good. Awesome. That's it. We're done. That's all you need. It happens that this function is not symmetric. F of -x. Say it again. Good. So let's graph. Obviously, I will plot what I have. From left to right, can anyone help now? Which points will you plot? Well, I have to plan ahead a little bit. Maybe I will use a different scale for the y axis because I have this 12 and this is -4, -3, -1. So which point will I plot first? -4, 0, -3, 0, -1, 0, and 0, 12. 2, 4, 6, 8, 10, 12. Let's come up with an idea. Everyone can look at the graphing calculator and come up with a graph. That's not the issue. We don't want to do that. So it's coming from, so first of all, I have to make myself a note, this note. Cross, cross, but at -1, it's a cross flat. cross, cross. So it's coming from negative infinity, crossing at negative 4, 0. Okay, fine. Then it's crossing at negative 3, 0. If it's crossing at negative 3, 0, it has to have a turn here. Then it has to come back. It has to have another turn because it crosses at negative 1, 0 again, but this time in a different way. In this way. Not straight. Now I really don't know what happens here. So it could do this and go directly to positive infinity. That's what I assume it is. There is nothing else in there. Nothing else can happen. So straight up through this point. So this is the graph of x plus 3, x plus 1 cubed, and x plus 4. Now we're ready to look at the graphing calculator and confirm everything we came up with. So please plug it in. That's why I'm kindly asking you to redo the tests till the end of the semester, because we always get to, it happens to me too. I get to step 10 and I forget step 1. It's very possible. So please redo the problems on those tests. Test 2 coming up. X plus 3, close the parenthesis, open another parenthesis with x plus 1 to the 3rd power. Put the caret and 3, and then don't forget to come down from there and x plus 4.
Yeah.
Okay, so now I'm looking at the viewing window, and definitely I have to select above 12 to see what happens. I don't want to go too far to the left. So in the viewing window, I see negative 4, so negative 6 is good enough. How far to the positive side? 2 is good enough. I'm talking about x. You're way ahead of me. That's awesome. So now the minimum, y minimum, I see here I have negative 10. I don't need negative 10. So probably negative 4 would be good enough. But now y maximum should be about 16. I need to see the y-intercept. And I can put a scale of 2 for the y-axis. So as expected, it crosses at negative 4, 0. It crosses again at negative 3, 0. Look at the difference. See the difference? See how this cross, multiplicity 1, this cross, multiplicity 1, this cross, multiplicity 3. Chris, please put that away.
What?
Oh, you have? Okay.
Yes.
Good. Just making sure. Okay? So then it crosses at 0, 12 going to infinity. You see the difference between multiplicity 1 and multiplicity 3? It's totally different. It crosses only once, of course. All of them cross once, but very slowly. It approaches the x-axis slowly. Okay. So we had 3 examples. Do we feel a little bit better about this? It's not such a big deal. It looks very difficult initially. And yes, I know it took me like forever to explain all those topics. Okay. In the next section, we are reviewing the long division. So, long division, that's one item here, 3.3. Long division. We can look at the synthetic division if you'd like, but I think the long division is good enough. Synthetic division is not always applicable. The long division is always applicable as long as the denominator has at least 2 terms. So P of x divided by Q of x, and Q of x at least a binomial. Not a monomial. Okay, so let's look at an example. Let's say 21 on page 392. And here it is, 4x cubed minus 3x squared plus 3x and minus 1 divided by x minus 1. I know you remember this, and I know I promised to finish 2 minutes early today because I held you over last time, and I apologize for that. Okay, so the numerator is a polynomial in descending order. The denominator is a polynomial in descending order, and no term is missing from the top. Degree 3 is there, degree 2 is there, degree 1 is there, degree 0 is there. If a term is missing, then I have to leave some room for it. But in this case, it's a simple situation. So I can start the algorithm. So 4x cubed minus 3x squared plus 3x minus 1 and x minus 1. We are asking ourselves these questions. X times what is 4x cubed? 4x squared. We go back and we distribute to both terms, change the sign, and write below like terms. 4x squared times x is 4x cubed minus 4x cubed. 4x squared times negative 1 is negative 4x squared. We have to change the sign because we must subtract. 4x squared minus 3x squared is x squared, and I bring down the next in line. Let's stop for a moment and see if you have questions. Yes. So I copy the numerator and I copy the denominator, and I'm asking myself, x times what is 4x cubed? The answer is 4x squared. 4x squared times x, it will be 4x cubed. Is that okay? So now when I go back and multiply, I get 4x cubed, but I have to subtract, so I have to change the sign. 4x squared times negative 1 will be negative 4x squared, but I have to subtract. That's why I have to change the sign. These two go away. Here I have x squared, and I bring down the next in line. Next question. X times what is x squared? Yes, a positive x. So x times x is x squared, but I have to subtract. X times negative 1 is negative x, but I have to subtract. Every time I subtract, I change the sign. So then I have 4x minus 1. X times what is 4x? Indeed, very good. No, at the top we never lie. So x times what is 4x? It has to be positive 4. So 4 times x is 4x, we subtract. And 4 times negative 1 is negative 4, we subtract. So this is the remainder. And we write the answer as the quotient 4x squared plus x plus 4 plus the remainder, which is 3 over x minus 1.